Okay, so we today also we will do gaseous law. We first do the Avogadro's law, then we will do ideal gas equation. Okay, so in our previous classes we have learned Boyle's law, Charles' law, Gay-Lussac's law. Okay, so today we will do another gas law, that is Avogadro's law. So what is Avogadro's law? See. What Avogadro's law state is that, see, it states that equal volume of all gases under the same condition of temperature and pressure. That means when temperature and pressure are constant. Okay, so under the same condition of temperature and pressure contain equal number of molecules. Okay, again I'm reading. Avogadro's law states that equal volume of all gases under the same condition and same condition of temperature and pressure contain equal number of molecules. So let's try to prove it mathematically. Okay, mathematically V proportional to N is the number of molecules when P and T constant, P and T constant, that means pressure and temperature constant. So we can write it this one, K4N. N is the amount of substance. N is the amount of substance. Okay, and N is actually the we can say what is N. N is the number of moles. Okay, N is the number of molecules in 1 mole of gas. N is the number of molecules. Okay, N is the number of molecules in 1 mole of gas, and you know that is equals to 6.022 into 10 to the power 23, and it is known as Avogadro constant. This value, that is 6.022 10 to the power 23, is known as Avogadro constant. Okay, and K4 is the proportionality constant. Now we can say that all gases, okay, so from this we can also say that all gases containing equal amount of substance occupy the same volume at the same temperature and pressure. We can say this thing also, that all gases containing equal amount of substances, okay, occupy the same volume at same temperature and pressure. So that is Avogadro's law. Avogadro's law is volume amount relationship. Okay, so that means at constant temperature and pressure, same amount of gas will have the same amount of volume. Okay. Now, next is relationship between density. As is amount is the volume and amount relationship, so we have to see the relationship in respect to density. Okay, so how we can calculate number of moles? Okay, number of moles. See, number of moles of a gas can be calculated number of moles of a gas okay, number of moles of a gas can be calculated N equals to small m by capital M, where M is what? M is the mass of the gas under investigation. Okay, M is the mass of the gas under investigation, and capital M is what? Capital M is equals to molar mass. So we can calculate the number of mole by small m by capital M. Small m is the mass of the gas under investigation. Capital M is equals to molar mass. So if we put the value, this value in this equation, what we can find that V equals to K4 small m by capital M. Okay. So we can rearrange this equation and can write M equals to K4 M by V. M by V is what? Mass by volume is equals to what? Mass by volume is equals to density. Mass by volume is equals to density. Okay, so that means we can say that the density of a gas is directly proportional to its molar mass. Okay, so we can say that density of a gas is directly proportional to its molar mass. Okay, boys, clear? If you have any confusion, you can ask regarding the Avogadro's law. At a given temperature, Avogadro's law states that at a given temperature and pressure, the volume of a gas is directly proportional to the amount of gas. That is V proportional to N. And N is number of moles we can calculate by given mass by molar mass. Okay, so if we put the value of number of mole into this equation, okay, then we will get the relationship M equals to K4D. That means density of a gas is directly proportional to the molar mass. Clear?
Yes, ma'am.
Okay. Now next we will do ideal gas equation. Next we will do ideal gas equation. Okay, so what is an ideal gas? A gas that follows Boyle's law, Charles' law, Avogadro's law strictly is called an ideal gas. Okay, so what is an ideal gas? We can say if a gas follow Boyle's law, sorry, okay, Boyle's law, Charles' law, and Avogadro's law. Okay, so a gas which follows strictly Boyle's law, Charles' law, Avogadro's law is known as an ideal gas. But such a gas is hypothetical. It's not possible for the gas to follow strictly the Boyle's law, Charles' law, and Avogadro's law. It is totally hypothetical. Because the gas which follow Boyle's law, Charles' law, and Avogadro's law, it was assumed that the intermolecular force of attraction between the molecule was negligible there. But this is not actually happening. So the gas which does not follow strictly Boyle's law, Charles' law, Avogadro's law are known as real gases. Okay, and real gases follow this law only under certain specific condition. Real gases are following Boyle's law, Charles' law, Avogadro's law in certain specific condition, and that specific condition is at very high pressure and at very low temperature. At very high pressure and at very low temperature, the real gases can follow the Charles' law, Boyle's law, and Avogadro's law strictly. Okay. So why this deviation, why this behavior deviation is take place in case of gases, we will learn in this chapter. Okay, in our next part we will learn. Now we will learn how we calculate the ideal gas equation. Okay, how we can derive the ideal gas equation. So let's see the three laws which we learned till now. The main three laws: Boyle's law, Charles' law, and Avogadro's law. Okay, Boyle's law, Charles' law, and Avogadro's law. These three laws can combine together in a single equation. Okay, Boyle's law, Charles' law, Avogadro's law can combine together in a single equation, and that equation is known as ideal gas equation. Okay, so let's start writing the equation. That like at constant temperature and when the amount is also constant, V proportional to 1 by P. It is known as Boyle's law. Okay. At constant pressure and when amount is constant, we can say V proportional to T. It is Charles' law. You also write with me, so it will be easy for you to understand. Okay, and at constant pressure and temperature, V proportional to N, it is known as Avogadro's law. Okay, it is known as Avogadro's law. So if we combine this equation, what we can see, V proportional to NT by P. See, V proportional to NT by P. Then we can write V is equals to R NT by P, where R is the proportionality constant. R equals to proportionality constant. Okay. Now, if we rearrange this equation, that is equation number 2, if we rearrange, we can write the equation like this: PV equals to nRT. Yes or no? PV equals to nRT. We can write the equation like this: PV equals to nRT. This equation is known as ideal gas equation. This equation is known as ideal gas equation. PV equals to nRT. Okay. R equals to, we can write PV by, R equals to, we can write PV by NT. So what is R? R is a very important factor. In gases, in ideal gas equation, R is a very important factor. If R is known as universal gas constant. Okay, or R is, we can say that universal gas constant, or we can also say that gas constant. Okay, it is universal gas constant or normal gas constant, we can say R. Okay, so till this much it is clear to you or not? Tell me. Ideal gas equation. Ideal gas equation is clear to you?
Yes. Yes, ma'am.
Okay. Now, when, let's see here, from this equation, when n equals to 1, that means for 1 mole of gas. When n equals to 1, that is for 1 mole of gas. Okay, then the equation will be PV equals to RT. For 1 mole of gas, the equation will be PV equals to RT. Now, our next topic is nature of universal gas constant. Nature of universal gas constant. So we know that what? PV equals to nRT, R equals to PV by NT. Okay, so we can say R, P means what? Pressure. V means what? Volume. N is moles. And obviously T will be temperature. Pressure means what? Force per unit area. Pressure is force per unit area. You have learned it in physics. So we can write F by A, force per unit area, into volume divided by moles into temperature. We can write it or not in this way. Then area is what?
Yes, miss.
Area is what? Length square. Area means what? Area means length square. Volume means, we can say length cube. Area means length square. Volume means length cube. So we can put the value over here now. See, F is length square into length cube divided by moles into temperature. Moles into temperature. So if we cut this one, so we can say F into length divided by moles into temperature. Force into length is what? Force into length is equals to work. So we can say R equals to work divided by moles into temperature. So we can say that R represent, sorry, R represent work done per degree per mole. Okay, so we can say that R represent work done per degree per mole. Clear? This one, this portion?
Yes, miss.
Okay. So next we will do numerical values of R. Very important. Very, very important. Numerical values of R. Numerical values of R. Very important. So what is the equation for R? R is equals to PV N T. Okay. So 4 equations are there. We'll just do only 2 because time will not permit, I think. So when number 1, when pressure is expressed in atmosphere and volume in liters. Okay, when pressure is atmosphere and volume in liter, then the value of R will be liter atmosphere per degree per mole. Then R will be liter atmosphere per degree per mole. Okay, let's see. R pressure is 1 atmosphere, so 1 atm into at one that means at 1 mole of gas at STP can occupy a volume of 22.4 liter. STP means standard temperature and pressure. That means at 1 atmospheric pressure and 273 Kelvin temperature, 1 mole of gas can occupy volume 22.4 liter. Okay, and here will be 1 mole obviously. At the same time, the temperature will be 273 K. So the value will be 0.0821 liter atmosphere mole inverse Kelvin inverse. Okay, the value and the unit, very, very important. Value and the unit you have to remember. It's very, very important. Now, next is when pressure is expressed as PA, that means in Pascal. When pressure is expressed as PA, that means in Pascal, and volume will be in meter cube. Volume will be in meter cube. Then R will be expressed in joules per degree per mole. Joule per degree per mole. So 1 mole of gas at STP when pressure is in bar, that means pressure is 1 bar and temperature is 273.15 Kelvin, then the gas occupy the volume that is 22.7 into 10 to the power minus 3 meter cube. Okay, when pressure is expressed in Pascal and at STP, 1 mole of gas can occupy the volume of 22.7 into 10 to the power minus 3. Let's put the volume in the equation. That means R is equals to 10 to the power 5 PA. Okay. At STP, the Pascal will be 10 to the power 5. Okay, into 22.7 into 10 to the power minus 3 meter cube divided by 1 mole into 273.15 K. Now, 1 Pascal, okay, 1 Pascal is equals to Newton per meter square. 1 Pascal is equals to 1 Newton per meter square. So we can write over here 10 to the power 5 is equals to Newton per meter square into 22.7 10 to the power minus 3 meter cube divided by 1 mole into 273.15 K. Yes or no?
Yes, miss.
So we can write the equation 8.314 Newton meter mole inverse Kelvin inverse. Now Newton meter is what? Joule. Newton meter is what? Joule. So we can say that 8.314 joule mole inverse can be Kelvin inverse. This value also you have to remember. Very, very important. This value also you have to remember. Clear?
Yes, miss.
Okay. Now next we will do that is combined gas law. Sorry. Combined gas law, that is we can, sorry. Now let us now we'll go to the ideal gas equation, that is PV equals to nRT. Okay, so the relationship of the simultaneous variation variable, if we do, so if temperature and volume and pressure are fixed, okay, and if temperature is T1, volume is V1, and pressure is T1, so we can write this one like P1 V1 divided by T1 is equals to nR. Also, if temperature is T2, volume is V2, pressure is P2, we can write P2 V2 by T2 is equals to, that is N and R will be constant because number of moles, and obviously R is a gas constant. So from this equation, what we can write? P1 V1 T1 is equals to P2 V2 by T2. Yes, this equation P1 V1 by T1 equals to P2 V2 by T2. This equation is known as combined gas law. Okay, when the amount of gas is fixed, when N is constant, for a gas P1 V1 T1 is equals to nR. If the pressure increases to P1 to P2, volume is increases to V1 to V2, and temperature is also increases to T1 to T2, then it is become P2 V2 T2 by nR. So P1 V1 by T1 equals to P2 V2 by T2. This equation is known as combined gas law. Okay, clear?
Yes, miss.
Okay, now next, the last topic what we'll do, density and molar mass of a gaseous substance. Gaseous. Density and molar mass of a gaseous substance. Okay, so ideal gas is equals what? PV equals to nRT. We can write the equation like this: N by V equals to P by RT. Now replacing N equals to small m by capital M. Okay, given mass my molar mass of the gas. So we can write this equation M by mv equals to PRT. Yes. Now m by v is what? D, that is density. That is D by m Okay, B by M equals to PRT. If we rearrange the equation, the capital M equals to DRT by P. See, this is the relation between density and molar mass of a gas. This is also the relation between density and molar mass of a gas. Clear?
Yes, miss.
Okay, so